Hey guys, welcome to my channel. Today I wanted to talk about why is the derivative of sine x equal to cosine x. Firstly, it might seem unintuitive or there might there doesn't just seem to be a linkage between these two. Um when I first learned about this, I was told to just memorize this. Um it was Yeah, I mean, it's kind of easier to memorize, but I always wanted to think, why is it like that? Why is it not, say, tangent x? Why is it not like x squared minus 1 or whatever? Why is it equal to strictly cosine x? And today I wanted to talk to you about the intuition behind the calculation of this. So, I believe you all know the definition of derivatives is the limit evaluated. That is the definition, so I'll just write it down for now. So you guys should notice that is the definition. So yeah, so we know function of x is equal to sine x because that is the function we defined it to be right here. So we'll just sub in sine x plus h minus sine x over h. Now you might be like, well, I'm kind of stuck. How do I go on actually? Because I can't seem to like try to simplify this even more. But that is where this formula comes into play. So I believe you guys would notice, or if you don't, now I'm going to introduce you to this formula. It states that sine of bracket x plus y would be equal to sine x cosine y plus cosine x sine y. So today I'm not going to derive this formula, but if you want to see me derive this formula, just like leave a comment on something so I know and I will try to give you some intuition behind this formula. So let's continue with this. So now we have this formula. We just sub it into this, which is quite easy to do. But it might seem unintuitive as to why I would substitute in clunky this clunky equation into that, because it seems like I'm overcomplicating things. Like why am I substituting this? It makes the whole thing larger. Look, it's like making the whole thing larger. Why would I want to make the whole thing larger? But there's a trick to make this actually shorter. So as you can see, we have like terms here. So we have sine x and sine x over here. So we just factorize it, right? Yeah, simple. Easy peasy. Sine x cosine of h minus 1 plus cosine of x sine h over h. So now we have something plus something over something. And I want to separate this into two limits because I don't want to evaluate such a big limit. So I want to separate this into two fractions so I could separate it into two separate limits so that it's easier to evaluate for me. So plus, now I'm just separating the fractions and separating them into two limits. My handwriting is becoming worse. My bad. I'll try to maintain my handwriting throughout the video. Yeah. So here, you might say, so we have cosine x here and we have sine x here, and we're evaluating a limit of h. So we can actually, this is fun. We can actually kick them out of the limit because it doesn't really affect the results. I could multiply them on later, right? Now, Now, we're left with two easy limits. Well, I believe y'all will have seen this limit before. You can evaluate it using L'Hopital, squeeze theorem, and you get this would be equal to 1. It's a very popular limit. Let me use it. Let me use red so that you guys. I hate my handwriting. Okay, so this will be equal to 1. This limit equal to 1, not the cosine x. So I could write something like this. Now it's gonna come together. It's starting to come together, right? So now we're left with this thing. So of course you could just use L'Hopital, or you could plug it into a graphing calculator. You could plug it into just a normal calculator and like test out some values. Try to like go from like 10 to 1 to 0.1 and to negative 0.11 and then negative 10, and you see that this limit actually goes to 0. It approaches 0 times 0 plus cosine x. So at last, we're left with cosine x. Isn't this fun? Like, we took this and then through this whole thing, look at this. It's like we're making this into a whole big thing, and then we're like, at last, we're like compressing it back together into a short, simple equation. Isn't that fun? Okay, so guys, thanks for watching. This is my first video. I hope you guys like it, and see y'all for another math video or sciences. So, bye.